In the last video, we have seen what are the uses of dimensional analysis, and out of the three uses, I explained two in the last video, and the link of the last video is given in the description box. Now go through those videos, subscribe to the channel so that you are able to get the notification of the successive videos I am releasing. Couple of video used to be released within a week. माझी अशी योजना आहे की आठवड्यात कमीत कमी 2 ते 3 व्हिडिओ मी पाठवावेत आणि ते व्हिडिओ तुम्हाला पाहण्यासाठी तुम्हाला माझं चॅनल सबस्क्राइब करावं लागेल, जे मनोहर कबाडे नावाने आहे. मागल्या व्हिडिओची लिंक डिस्क्रिप्शन बॉक्स मध्ये आहे. आपण मागल्या व्हिडिओ लेक्चर मध्ये डायमेन्शनल अनालिसिसचा उपयोग काय हे पाहायला सुरुवात केली होती. त्यातली पहिली दोन उपयोग आपण सांगितली होती. The first use of dimensional analysis is to verify whether the given equation is correct or not. That is, to check the correctness of the given physical equation or to find out the truth of given physical equation. This is one of the use of the dimensional analysis. Then the second use of dimensional analysis is to determine the conversion factor between the unit of same physical quantity in different systems. For that we have taken two examples. One is, we proved that 1 Newton is equal to 10 to the power of 5 dyne. Newton is the SI unit of force and dyne is the CGS unit of force, and 10 to the power 5 is the conversion factor that is determined from the dimensional analysis. In a similar manner, with the help of dimensional analysis, we are able to find out the conversion factor between the unit of work in SI unit and CGS unit. 1 joule equal to 10 to the power of 7 ergs. Now hereafter we will go for the third use of dimensional analysis, that is to determine the relation between different physical quantities, or rather we say that to derive the physical equation that can be done with the help of dimensional analysis. आपल्याला माहिती आहे की भौतिक राशी एकमेकावर अवलंबून आहेत आणि त्यांचं अवलंबत्व, डिपेंडन्सी आपण इक्वेशननी मांडतो आणि ती इक्वेशन शोधून काढायची, ती इक्वेशन डिराईव्ह करायची, हे काम डायमेन्शनल अनालिसिसच्या मदतीने करता येतं. शाळेतलं पुस्तक वाचत असताना एक वाक्य माझ्या ऐकण्यात आलं आणि ते ऐकून मी खूप खुश झालो. त्याच्यामध्ये एक लय आहे. ते वाक्य असं होतं, दोलकाच्या दोलनाचा दोलनकाळ हा दोलकाच्या लांबीवर अवलंबून असतो. दोलकाच्या दोलनाचा दोलनकाळ हा दोलकाच्या लांबीवर अवलंबून असतो. इथे त्या वाक्याबरोबर आपण सुद्धा डोलायला लागतो. हे एखाद्या गाण्यातच 2 ओळी वाटायला लागतात. दोलकाच्या दोलनाचा दोलनकाळ हा दोलकाच्या लांबीवर अवलंबून असतो. इंग्रजीत याला आपण असं म्हणतो, द पिरियड ऑफ पेंड्युलम depends on the length of the pendulum. The question arises, if the period of pendulum depends on length of pendulum, whether it depends on mass of the pendulum or not. At the same time, what is another factor on which the period of pendulum depends on? And if period of pendulum depends on length of the pendulum, then what is the relation between the period of pendulum and the length of the pendulum that can be determined with the help of dimensional analysis. We will start with what do we mean by the pendulum. What pendulum is? Pendulum is a heavy metallic spherical bob suspended by a weightless inextensible string. Weightless is not possible, lightweighted string. Now, when the pendulum is suspended with the help of a lightweight string from a rigid support, now the pendulum remains at rest here, therefore this is said to be the equilibrium position of the pendulum. At equilibrium, various forces acting on the pendulum are, one is the weight of the pendulum and other is tension that has been developed in the string. When the pendulum is displaced from its equilibrium position and released, it used to oscillate on either side of the equilibrium position. Time required by the pendulum to complete one oscillation is the period of pendulum, and we say that the period of pendulum depends on the length of pendulum. The question arises, how it is so? One more thing that you note here is that the oscillation of the pendulum is governed by mg, that is the weight. Weight is governed by acceleration due to gravity. Therefore, period of pendulum may also depends on acceleration due to gravity. And we have to see whether the period of pendulum depends on mass of the pendulum. Therefore, I will write an equation here. T is equal to some constant k, which cannot be determined by the dimensional analysis. It is the limitation of dimensional analysis. Let this period of pendulum is given by some constant k, this length raised to a, acceleration due to gravity b, and the mass c. Then, in order to derive the relation for the period of pendulum, what is our task is that we have to determine the values of a, b and c using dimensional analysis. हा पेंडुलम काढलाय, हा इक्विलिब्रियमच्या दोन्ही बाजूला ऑसिलेट होतोय. याच्या ऑसिलेशनच्या एका दोलनाचा काळ म्हणजे दोलन काळ असतो पिरियड ऑफ पेंडुलम, तो लांबीवर अवलंबून आहे म्हणून एल रेज टू ए, ऍक्सेलरेशन ड्यू टू ग्रॅव्हिटीवर अवलंबून आहे जी रेज टू बी, मासवर अवलंबून आहे की नाही हे शोधायचं आहे म्हणून एम रेज टू सी. असं जर आपण इक्वेशन लिहिलं तर आता आपल्याला काम असं आहे की ए बी आणि सी च्या किमती काढायच्या, आणि एबीसी च्या किमती कळाल्या की आपण पिरियडचा फॉर्म्युला डिराइव्ह केला असं सांगू शकतो. No, the job is simple. We will take dimensions on either side of the equation and equating the dimensions we will find out the values of A, B, C, and knowing the values of A, B, C we are able to find out the formula for the period of oscillation of the pendulum. Now, what capital T? Capital T is the period of pendulum. Therefore, I will write it as T, and obviously it is T raised to 1. A singular capital T is that. No, K is constant. Obviously, it's a constant which is a number which cannot be determined by the dimensional analysis. Therefore, it has a limitation. We are not able to find out the value of K with the dimensional analysis. Then L is the length. I will take L raised to 1. Now, it is raised to A. The dimensions of the length are unit of length raised one time. Then the dimensions of acceleration due to gravity. Actually, acceleration due to gravity is the acceleration of a free falling body. We know that according to Newton, every body is attracted towards the earth with a force that is called as gravitational force. And therefore, every body under the influence of gravitational force is acted by a acceleration that is known as acceleration due to gravity. And what acceleration is? Acceleration is a rate of change of velocity, dv by dt. Therefore, what are the dimensions of acceleration? I will write the first unit. Unit of acceleration is meter per second per second. Therefore, it is meter per second square. Unit of acceleration is meter per second square. If unit of acceleration is meter per second square, then meter is the base unit of length and t is the base unit of time, and per second square it is t raised to minus 2, it is raised to b. These are the dimensions of acceleration. If these are the dimensions of acceleration, then mass is measured in kilogram, the base unit is kilogram, then here it is alone, single, therefore m raised to 1 raised to c. We will simplify this equation. Therefore, what we will get, the t raised to 1 is equal to some constant k, it is L raised to a, L raised to b, t raised to minus b, and m raised to c. Simple thing that we have done. L raised to b, t raised to minus 2b, m raised to c. Using this, what you will see that here I had written it alone t raised to 1, means actually what it is, m0, L0, t1, k, it is L raised to a plus b. L raised to a plus b. Here it is L raised to a, L raised to b. In product there is sum of the indices. Then you will get t raised to minus 2b and m raised to c. Now here m raised to c, m raised to 0, equating these two. First I will write what c equal to, c equal to 0. Then t raised to minus 2b and here t raised to 1. Therefore, I will write minus 2b is equal to 1. Here t raised to minus 2b and here t raised to 1. Therefore, minus 2b is equal to 1 and hence I will write what b is equal to minus of 1 by 2. The indice b here is minus of 1 by 2. Just we find out. And next, a plus b, L raised to a plus b, but here L raised to 0. Therefore, I will write here a plus b equal to 0. But just now, what we have determined, b is minus 1 by 2. Therefore, a minus half is equal to 0. Therefore, a is equal to 1 by 2. Like this, we got the values like this one. What a is equal to 1 by 2. What b equal to minus 1 by 2. And what c equal to 0. Using these things, we are able to determine the equation for the period of pendulum. Here, the job is simple. How we will determine this one? This capital T is equal to what k? K is a constant. It is to be determined experimentally found. The value of k is 2 pi. Then what L? L raised to a. but actually what A is equal to 1 by 2. Therefore, I will write here L raised to 1 by 2. What next is G? G raised to B. But what actually B is? Minus 1 by 2. Therefore, it is G raised to minus 1 by 2. And what next is M? M raised to C. But what C equal to? C equal to 0. Therefore, finally we got an equation that T is equal to 2 pi L raised to 1 by 2, G raised to minus 1 by 2 and M raised to 0. Raised to 1 by 2, what it means that? Raised to 1 by 2 means that it is a square root and hence finally we get an equation T is equal to under root of L. Root L means L raised to 1 by 2 divided by G. As it is minus 1 by 2, it should be in the denominator, and this is the final equation that we get for the period of pendulum using dimensional analysis. आता आपण डायमेन्शनल अनालिसिसच्या तिसऱ्या युजचं दुसरं एक्झाम्पल पाहणार आहोत. We will see the second example of dimensional analysis to derive the relation between physical quantities. That is interesting and little bit new for you. We know that motion of particle along the circumference of a circle is called as circular motion. It's a circular motion. Let us consider an object is performing circular motion along the circumference of a circle. This is an object of mass m moving along the circumference of a circle R with a constant linear velocity v. Then the force which is responsible to revolve an object in a circular path is the centripetal force. Much of the details of this we will see in the successive chapters, topics that is to be covered in the 11th class or 12th class. At this stage, you have to only remember that the motion along the circumference of a circle is called as circular motion. The best example is when you tie a stone to a thread and revolve in a circle, then its motion is a circular motion. Go fun. दुरीला दगड बांधून आपण फिरवतो. For this circular motion, for any motion, there is a need of a force. Here, the force which is responsible for this circular motion is the centripetal force. It is called as centripetal force because this force is along radius and towards center. Therefore, this force is called as the centripetal force. Then, question arises, what will be the formula for the centripetal force, or how to derive the centripetal force with the help of dimensional analysis? From the figure itself, it indicates that the force is the product of mass and acceleration. Therefore, force definitely depends on mass. Therefore, we have taken the mass of the object as m. More is the force, more is the change of velocity, or more is the velocity. Therefore, force depends on velocity with which it is moving. At the same time, this force also depends on the distance from the center at which the object is revolving. Therefore, this force depends on the radius of the circular path. Now, our task is to determine the relation between mass, velocity, radius with the force. Therefore, simply I will write the centripetal force is equal to some constant k, mass raised to a, velocity raised to b, and radius raised to c. In order to derive the relation, I have to find the values of a, b and c using dimensional analysis. Again, the job is simple. What we will do, we will write dimensions on either side of the equation, and then we will equate the equation, and finally we will find out the values of a, b, c. Putting the values of a, b, c, we will get the relation. Here, this is the force. What are the dimensions of force? We know that the dimensions of a force are m1, L1 and t minus 2. K is constant. Its value is determined experimentally. M raised to 1 raised to a. Here mass is alone. Here velocity. We know that the dimensions of velocity are L1 and t minus 1 raised to b. How velocity is? Velocity is a displacement upon time, and the unit of velocity is meter per second. Meter is the base unit of length and second is the base unit of time in the denominator. Therefore, L1 t minus 1 raised to b, and this is radius. Radius is measured in terms of c. Therefore, in terms of length. Therefore, it is L raised to 1 raised to c. Then I will write dimensions on either side of the equation. M1, L1, t minus 2, some constant k, m raised to a, L raised to b, t raised to minus b, and L raised to c. This is the simple thing that we have done here. L raised to b, t raised to minus b, and L raised to c. Now, using this, I will write here m1, L1, t minus 2 on left hand side of the equation, and to the right hand side of the equation, I will write here m raised to a, L raised to b, L raised to c. Therefore, it is L raised to b plus c. L raised to b plus c, and at the end, it is t raised to minus of b. Now, you will see on either side of the equation the dimensions are written, and equating these dimensions we will write. आता तुम्हाला कळलंय दोन्ही बाजूला डायमेन्शन्स आहेत आणि याच्यावरून ए बी सी च्या किमती कळतात. आता इथून सुरू करू आपण. What minus b is equal to minus 2. Therefore, b is equal to 2. This is the one thing that I got. What next is b plus c is equal to 1. b plus c is equal to 1. That is what b is? b is 2. Therefore, 2 plus c is equal to 1. As b is 2, it is 2 plus c is equal to 1. 2 plus c is equal to 1. Therefore, what c is equal to? 1 minus 2, it is equal to minus of 1. This is b equal to 2 and c equal to minus of 1. And from this, b minus b is equal to minus 2, therefore b is equal to 2. b plus c is equal to 1, b plus c equal to 1. From that I got c is equal to minus of 1. What a equal to? A equal to 1. This is a equal to 1. Now, with this, I got the values of these variables. This is a equal to 1. This is one thing that I got. What next is b? What b equal to? b equal to 2. This is the other thing that I got. And what c? c is equal to minus of 1. This is the third thing that I got. Using these relations, we are able to find out the formula, or we are able to derive the equation for the force in a circular motion, that is the centripetal force. What the centripetal force is equal to? Centripetal force F is equal to, here constant of proportionality experimentally found, its value is 1. Look, m raised to a. But a equal to 1. Therefore, I will simply write it as m. Then v raised to b. But what actually b is? B equal to 2. Therefore, I will write here as v square. B equal to 2. And what at last is r raised to c. What c equal to? C equal to minus 1. Therefore, r raised to minus of 1. This is the expression for centripetal force. Conveniently, r raised to minus 1 can be written as 1 by r, and hence the final equation for the centripetal force is mv square divided by r. And like this, using dimensional analysis, we are able to find out the equation for centripetal force in a circular motion. F is equal to mv square divided by r. या व्हिडिओ लेक्चरमध्ये आपण 2 युजेस पाहिले. मला वाटतं या गोष्टी तुम्हाला कळल्या असतील. व्हिडिओ डाउनलोड करून परत परत बघा आणि फिजिक्सच्या अभ्यासाचा जर्नी एकदम एन्जॉयबल करा. आय होप यू आर लाइकिंग दिस व्हिडिओज. सी दोज रिपीटेडली and make your subject more and more enrich your knowledge by seeing these videos and reading the different books or the books prescribed for you. Thank you for watching this one. I need your support. Thank you very much.